x. We all know how to do that, right? Find a domain and range of 2 to the x. Well, what's the domain? What's the range? Graph the inverse. Well, what is an inverse? Good. It switches x and y. I didn't tell you to find the inverse. I just said graph it. So I plotted the point 0, 1. So what would the inverse of that point be? I plotted the point -1, 1/2. What would the inverse of that point be? 1/2, -1. I plotted 1, 2. What would the inverse of that be? And I could have plotted 2, 4. And then I would get 4, 2. Does everyone agree? I could do this all day long, but end up getting that graph right there. That graph is what we're going to be talking about most of the day today. What in the world that graph is. What would the domain of that graph be?
Yeah.
Where's the first time I touch it? Time out. What did I do to find the inverse? So wouldn't the range become the domain? And the domain would become the interesting. Makes sense. Okay, so that's what we're going to be talking about today is the inverse of 2 to the x, or any exponential in general. To find an inverse, we switch x and y, right? And then we would solve for y. And then we hit kind of a catch-22. To solve for y, we normally use an inverse. Like if we're solving an x squared, we use a square root because those are inverse operations, right? And we're stuck because we don't have an inverse. We're trying to find an inverse. Though we don't have an inverse to find an inverse, catch-22. Math people had that same problem. Like, problem. So they're very creative and they just gave the name. So y is the number 2 is raised. Yes. That's the inverse of 2 to the x, right? You can imagine that got very tedious to write. So they gave that a name because that's too much work to write. And they called it log base 2 of x. It is a Latin word. Logarithm is a Latin word. So all they're saying, all a logarithm is the power that 2 is raised to get x. That's it. That's what a logarithm is. It is the inverse of an exponential. Yes. Because the base was 2. So if it were 3 to the x, what do you think the inverse would be?
3.
Log base 3. So that's what a logarithm is. It looks really scary because it looks like it has a lot of letters in math. And it's because they're taking this sentence and giving it a name. But exponentials been pretty easy the last couple days. This is just the inverse of an exponential. So if we think about it in that context, logarithms are much easier. So log base 2 is the inverse of 2 to the x. We graphed it in the bell ringer. Couple of pieces of information about a logarithm. It has a vertical asymptote. Remember, an exponential had a horizontal asymptote? Well, if I switch x and y, it now has a vertical asymptote at x equals 0. Vertical asymptote, it does not put that line at x equals 0. Has an x-intercept of 1, 0. Well, if 0, 1 is on every exponential, wouldn't 1, 0 be on every logarithm? Makes sense, right? The domain of an unshifted logarithm is 0 to infinity. The range is negative infinity to infinity. And well, what are some other points we can plot? Well, 1, 0, so I can plot. 0, 1 is on an exponential, so 1, 0 is on a logarithm, right? Remember, negative 1 and 1 over the base was on an exponential, right? So wouldn't 1 over the base, negative 1, be on every logarithm?
Yeah.
Right? And if 1 at the base was on every exponential, wouldn't the base, comma 1 be on every logarithm?
Yeah.
So those are 3 points we can always plot on a logarithm. We'll spend more time graphing tomorrow, but those are some important things we'll look at tomorrow when we're graphing. Today we're just going to get some familiarity with what in the world a logarithm is and try to take some of the fear out of it. Most of the time, once people really learn what a logarithm is, it's not near as scary as it was when you just saw the word in math. We just don't like letters in math, right? So if we figure out what those letters mean, there won't be so terrible. Before I go into more, let's just graph log base 4 of x. What do you think log base 4 of x is the inverse of? 4 to the x, right? And now I'm not going to actually graph 4 to the x, but I'm going to think about those 3 points. Well, what are the 3 points I'm talking about? My inverse is 4 to the x. What are 3 points that should be on this graph? Okay, 1, 0. 1, 0 is on every logarithm. Do you agree? So if you're graphing a logarithm and it has no transformations, you might as well start with that one. Now, normally 1, 4 is on the exponential, so what would be on the logarithm?
4, 1.
4, 1. And negative 1, 1/4, so what would that translate to? 1/4, negative 1. Everyone see where I'm getting those 3 points? Okay, so remember, side note. On that function, we have these 3 points. So on the inverse, which is log base 4,
Oh. Please log for the inverse.
right. So we learned on this slide that that just means the inverse, the power that 2 is raised to the x. So that's all that means. So it's just the inverse of 4 to the x. Okay. Logarithms are scary, exponentials are not. If they are truly just an inverse, couldn't I rewrite it as an exponential every time I see one? Like, in your brain, when you do the square root of 9, don't you say, what's squared is 9? Don't you do that? So, when we see a logarithm in our brain, we're going to think exponential. So, anytime you see a logarithm, and this is read log base b of y, is how you read that, we're going to change that to be an exponential. We're going to rewrite it to be an exponential. And so, log base b of y, remember the logarithm is the power, is the exponent. So, how are we going to rewrite that? And I learned this trick in high school, and everyone I've taught still uses it. I recommend it. I'm going to draw a little circle. B to the x and then a y. So I'm going to do a little circle there. What that little circle tells me is how to rewrite this as an exponential. b to the x equals y. These two statements are completely equivalent. You're just switching the x and y. So, b to the x equals y is the exact same thing as log base b of y equals x. Or log base b of y is the power you raise b to get y. You need to know that conversion. At the end of this chapter, we will put that on a note card. This little circle thing. You don't have to do it yet. I'll probably put some other things on the note card with it. But this is the most important slide of the day, is what in the world a logarithm is and how we're going to work with it.
So we're not going to like do x equals log and then like make another log and then
We'll solve logarithms later. Today we're just learning what in the world is. Do other things with it later. But for today, just a little bit of taking the fear out of it. That's what we're doing today. Figuring out what in the world this thing means. Learning it's not as terrible as people really know.
wait, I'm thinking is log like power.
We'll talk about that. Just a second. Okay, so before we talk about that, let's talk about this. Log base 2 of 128. That looks scary, right? Looks really scary. I don't know what that means. But if I had to find log base 2 of 28, I would want to know what in the world does it mean. So I'm going to use a little circle thing. This actually tells me to rewrite each equation in exponential form. So I'm going to take this logarithm, turn it into an exponential. I'm going to use the little circle thing. So, draw a little circle. If I'm writing it in exponential format, I don't want to write logarithm anymore, right? I want to write the exponential. So the exponential is 2 to the 7th power equals 128. Doesn't matter. 128 equals 2 to the 7th is over. So 2 to the 7th equals 128. Which one of those makes more sense in your brain? Second one, right? You see why we would want to do this? Sometimes just a rewrite makes me go, oh, that's what that means. Okay, that's sure. 2 times 2 times 2 times 2 times 2. I can find that. It's probably 128. Any questions about that one? Then you probably did something wrong because they. If they are giving you just, hey, this equals this, it should work out. So it's not doing typo on a test. Right. Now, a lot of, as you mentioned, variables, a lot of these will be things where you have to find a variable, so you won't be able to do that check always. But if you are on a test and that's the question, do the check. It better work out. Or you probably did something wrong. Okay, let's rewrite this one. You try this one. Do a rewrite. I want to know what is the exponential equivalent to log base 4 of 1 equals 0. What do we get?
4 to the 0 equals 1.
Let's try it. Little circle thing, 4 to the 0 power equals 1. Is 4 to the 0 power 1? Yes. Would you agree log base anything of 1 is going to equal 0? Because anything to the 0 power is 1? So we learned something about logarithms just from that rewrite. It's interesting. Okay, now I want to go backwards. It is a little tougher to go backwards. So when I do that, I'm going to side note on my paper. Log base b of y equals x. I'm going to do the little circle thing on the side of my paper and write b to the x equals y. I would always do that side note when I'm working this way because I don't have a full circle thing to help me get there. I've had a few people try to make a full circle thing and it doesn't seem to work out quite as well as the other ones. Key things to remember, the base is always the base. Always stays the base. Okay? Key thing to remember. The exponent is what the logarithm equals, and then the other number would have to be the y. So, what is the base here? 10. So this is log base 10. The exponent is what the logarithm equals, right? So log base 10 of 1,000 equals 3. Now, how many of you thought it was easier on the last slide than this slide? Me too. So what should you do really quick before you move on to the next problem? Check it. 10 cubed equals 1,000. Did we do it right? If you didn't do it right, you had 3 numbers. Try it. Fix it. Right? You just try to get rearranged and get it until the circle thing works out right. Does that make sense? Okay. What's the base on this one? So log base 1/2 of what? So 1/2 to the -2 equals 4. Did we do a good job? So that's how you convert back and forth from logarithms to exponentials and exponentials to logarithms. There are 2 special logarithms that you need to know. This was James's question earlier. He said, is a logarithm like ln? Sort of. There are 2 logarithms that are used so often that they get special names because mathematicians are notoriously lazy and they got tired of writing the little bases on there. So there are 2 special logarithms, and the reason they're so common is e is a very common number in biology. We'll talk about that when we do exponential function applications. And 10 is a very common thing in our number system because we work in base 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We start over, right? And so scientific notation, things like that, a lot of the things we work with exponentials are base 10 because that's how our number system works. So these 2 are very common, so they get special names. Anytime you are on your homework and you see this, while you're new at this, put a 10 there, because that's what it means. For a while, it'll be a little confusing because you'll be like, what's the base, right? Speaking of, see the 2 log buttons on the front of your calculator? Log and ln. That's these. You can't use that logarithm button to get log base 4. How do you get log base 4? It's a good question, right? You go to alpha window, number 5 is log base. So if you do want to type log base 4, you go down to that log base button. Those 2 buttons are these 2 logarithms. Log base e and log base 10. We learned it a lot. Okay, so I want to do these by hand for practice. So that way we get familiar with what logarithms mean and how they work. Does that mean you have to do these by hand forever? No. You just learned where your log base button was, right? Yeah. So, would you use your log base button and type log base 2 of 8 in your calculator? You could do that. So, I'm not going to, because I want to practice figuring out again, taking some of the fear out of these logarithms a little bit. Well, that is scary. I don't understand that. What would I do to make it understandable? I'm going to put an x there, and I'm going to write it as an exponential. What would it be as an exponential? 3 to the x equals 9. Well, you tell me. 3 to what power is 9? 2. Why 2? 3 squared is 9. So that's logarithm equals 2. Try it in your calculator. See, that's what it says. I'm tough on this, but I'll explain things to you. So log base 3 of 9, did we get 2 when we typed that in our calculator? Does this take some of the fear out of that? understand where in the world our calculator is getting the 2, right? It's not magic. It's not some weird thing with lots of letters. It's just the inverse of an exponential. So what about this one? What would I rewrite to answer the question? 2 to what power is 8? So you tell me, 2 to what power is 8? 3. 2 times 2 is 4. 4 times 2 is 8. So 3. Makes sense? 3 to what power is 1/9? How in the world do I get a fraction in it from an exponent? Negative exponents make fractions, right? And then 3 squared is 9, so negative 2. This is not horrible at all, is it? Even by hand it's not horrible, and not to mention you have a calculator that does it for you, right? This is not bad. This one's a little bit tough. 5, 25, to what power is 5? What is 5 in relation to 25? It's a square root. How do I get a square root from an exponent? How do I get a square root as an exponent? Properties of exponents. What is the same as a square root? Say that, Jessica. A fraction. Good. And what fraction? 1/2. So your calculator will probably tell you 0.5. It's because it's a square root. Interesting, right? Okay. Here's one. Think of one that's tricky. Log of 1. First of all, it is 0. It doesn't matter what the base is, does it? Forget that, though. What is the base? 10. So, on my homework, if I come to one like that, put a 10 there. That way you know what in the world you're doing. So this is asking 10 to what power equals 1. Now, some of you answered it without even knowing the base because you know that anything to the 0 power is 1. So log of 1 has to be 0. Log base 4 of 1, log base 5 of 1, log base of million of 1, doesn't really matter. It has to be 0. 9 to what power is 27? Okay, so calculator, did the calculator tell you that, or did you figure it out? Okay, 1.5. How high? What's 1.5 as a fraction? What's the fraction equivalent of 1.5? 3 over 2, right? What does a 3 over 2 power do? What's the 2 do? The fraction. Square roots it, doesn't it? Square root of 9 is 3. 3 cubed is 27. Strange one, but makes sense that the calculator said 1.5. 2 to what power is negative 4?
No really.
Why no real answer? You can't raise a positive number to an exponent and get a negative number, can you? Remember me telling you the domain of a logarithm was 0 to infinity? You cannot plug a negative number into a logarithm. It doesn't make sense because this